Hello everyone. So in the last video we solved remove duplicates from sorted array 2, and in this video we are going to solve majority element. So without any further ado, let's get started. Okay, so given an array of nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. So in the example 1, the length of the array is 3 and n by 2 is 3 by 2, that is 1.5, which means 2 times it should exist. So 3 is the only element that exists greater than 2 times. So the answer will be 3. In example 2, the length of the array is 2, 4, 6 and 7 and the half of that is 3.5. So 4 times the element should exist. So 2 is the element that exists 4 times. So as per the question, we have to return the element that exists at least n by 2 times. Okay. So there are two approaches to solve the problem. So the first one is naive, and the second one, obviously the follow-up question, the better approach, that we have to solve the problem in linear time and using big of one space. So first we will discuss the naive approach. First we will sort the elements, and when you sort the elements, if an element is occurring more than or equal to n by 2 times, then we have to only check for the element at n by 2 position. If the element at n by 2 position exists for more than n by 2 times, then we will return that element. So let's see an example. So we'll see the second example here. Okay, so in this example, we have 4 times 2 and 3 times 1, and the total length is 7, and half of which is around 3.5, which is equivalent to, let's say, 4. So n by 2 is 4. So when we arrange these elements in sorted order, we will get 1, 1, 1, and 4 times 2. So the element at n by 2, that is around 3, 0, 1, 2 and 3, this element. Now we will check for this element. If this element exists for more than or equal to n by 2 times, then we will return this element. So we'll start counting from this side and we will check if the element is equal to this element, then we'll increment the count. Let's say initially this is the element, so the count will be 1 initially. So if this element is equal to this element, then we'll increment. If the element is equal to this, element is equal to this, and finally we will see if this count, or inside the loop we will check if this count is already greater than n by 2, then we will return this element. So we'll first code this and then we'll see the optimized version which works in linear time. So let's implement this. Okay, so the first thing is we'll sort this array which takes n log n time. So that is nums dot begin nums dot n. So we sorted this array. So our target element will be the element at n by 2th position. So we'll do nums at nums dot size by 2. Okay. So let's extract this. Size is nums by 2 and size by 2. Now we will run loop from I is 0 to I is less than size, and we will check if v at I is equals to num, then we'll increment the count. If the count is greater than size by 2, okay, then we'll return the number. Now we will return count is greater than sj by 2, number else -1. Also we have to initialize count to 0. We can initialize the count to 1, but in that case we have to check that at sj by 2 we should not be doing these operations because we already considered that element. Okay, so we initialize count to 0 so that we don't have to do that in the for loop. So now count is 0 and we will run from start to the end of the array and we'll check if this element at nums is equal to this number, then we'll increment the count, else we'll move on to the next iteration. Okay, and if in between the array the count is already greater than sz by 2, we will return from here. And after this loop, we already know that the count is not greater than sz by 2, so we can simply return -1 here. So let's see if this works or not. And our initial test case has been passed. Now we will submit this to see whether it can pass all the test cases or not. And our test case has been passed. Now we will see the optimized version which runs in big O of n time. Okay, so let's see the second solution itself. Okay, so the second solution is based on the voting algorithm. So for an element to be the majority element, it should occur more than n by 2 times. Okay. Okay, so to understand this second approach better, we will short this array. But as I said you that this algorithm will work in big O of n time. But just to make you understand this algorithm better, I will be shorting this array. So 3 times 1 and 4 times 2 we have. So this is an array we have. So we'll pick the first element as a majority element. Okay. So first element is majority and its count is also 1. Now we'll move to the second element, which is same as majority element, so we'll increment its count. Third element is also same, so we'll increment its count. Fourth element is different, which means it will reduce the majority element's voting. So it will reduce the voting. Fifth element will reduce the voting. Sixth element will reduce it to 0. Now the majority element 1 has a 0 voting, which means the new majority element will now be 2, which has a count of 1. So here we reduce the voting to 0. So the new majority element will be 2 and its count will be 1. Now we'll move to the last element, and this is same as the majority element. We will increment its count and finally we will return 2. But how can we be so sure that 2 is a majority element? Because for example, if you have array like this 1 1 1 2 2 2, in this case majority element initially will be 1 and then we will have count as 1. We will increment the count to 3, then this will reduce it to 2, this will reduce it to 1, this will reduce it to 0, and we say okay, now our voting for the majority element 1 is 0, so we will reduce or change the majority element to 2 and its count to 1, and we say that 2 is a majority element, but 2 is not majority element. So we can do is we can traverse the array and verify if the element we selected for majority is actually a majority element or not. But if you see the question here, they says that you may assume that the majority element always exists in the array. So the majority element you got is actually the majority element, but if the question did not mention that you may assume that the majority element always exists in the array or something like that, then you should verify if the element you are getting as a majority element is actually a majority element or not. Now let's run this algorithm for another example. So let's say instead of 2 here, we'll take this example 3 ones, 2, 2, 2 and 1. Okay. So now this is not sorted. So we'll run on this. So majority element initially will be 1 and its count is also 1. Now we move to second element. It will increment the count. Third element will increment the count. Fourth element will reduce the voting to 2. Fifth element will reduce the voting. Sixth element will reduce the voting and itself become the majority element. So the new majority element will be 2 and its count is 1. Now the next element. It is different from this element. It will reduce the voting to 0. Now since the voting is 0, we will make this element as a majority element and its count will be 1. And finally we will return 1 as a majority element. Now, as I told you, you don't have to check whether this element is actually a majority element or not, because the question mentions that we can assume that an array always has a majority element. So this is the optimized version of this algorithm where the solution works in big O of n time. Now we'll implement this. Okay. So first we'll create voting, which is initially 0 for first element. So the majority element will be at nums of 0. So we consider this as a majority element. Now we'll run for I is 1, 2. Now if the nums at I is equal to majority element, then we will increment the voting for this element, else we will reduce the voting. And if voting is not there, 0, so what do? We'll reset the voting to 1 and new majority element will be this element. Okay, finally we will return the majority element. Now let's see if this works or not. It should be returned, and our initial test case has been passed. Now we will submit this, and our solution got accepted. Just to recap what we did, so we choose the first element as a majority element, and the voting is 1 for this element for itself. Okay, now from 1 to end of the array, we'll see if this element is equal to the majority element, we will increment the voting. Else if this element is not the same, then other element might be the majority element, right? So we'll reduce the voting, and if the voting becomes 0 for that element, then we'll vote, or we will select this element as a majority element and voting will be 1. And finally we will return the majority element, because we are sure that this is the majority element. As per the question, that we may assume that there is always a majority element in the array. So that's it.